So what do you think we need to know to calculate the theoretical probability of winning? What do you got, Brennan?
How many of each color are in the bag?
Good. How many of each color? Starbursts in the bag? Anything else?
How many total winners in the bag?
Good. The total. We need to know the total. Anyone want to give us a guess? What do you think is in the bag? Owen says 6 total. Any guesses on how many of each?
Just 4 red and 2 yellow.
So close. So close. We're going to write it down. We have 5 red and 2 yellow. 5 red and 2 yellow. So what you're looking at right now is a tree diagram. We're going to start the game. We do tree diagrams when it's without replacement. That's why I had you underline this before we started the game. Without replacement. It means I'm taking out my starburst and I'm not putting it back. So these become dependent events. Okay? Let's first just think about the first, when I pull the first starburst out. We have a total of 7. How many are red? 5. So I'm going to write in this box my first fraction. 5 out of 7. Before I pull any starbursts out, how many are yellow?
2 out of 7.
So 2 out of 7. Now, because I'm not putting my starbursts back, what is going to change about our second pull? What do you think? 4 out of 4 out of 6. All of these are going to change to out of 6. So let's put this all out of 6. So when we're doing probability or an experiment where I'm not replacing things, my total changes. And now let's talk about this. If I pull the first starburst as red, how many reds will be left for the next one? 4. Are we okay with that? It's going down. If I pull the first one as red, how many yellows are possibly left? 2. If I pull my first one as yellow, how many left are red? 5. And then yellow, that's going to be 1 out of 6. Are we okay with how we started building the tree diagram? Here's what we call our end probabilities. Okay? And what we're going to do is we multiply. So make a big note. We're going to multiply. Now, you can do this 2 ways. You can change the fractions to decimals and multiply those, or you can multiply your fractions. I'm just going to start by multiplying my fractions. Can anyone remind us, how do we multiply fractions? That's cross multiplication.
Across?
Just across, the tops, the bottoms. So we get 20 out of 42. Can you divide that and tell us what decimal should go here? 47.6. I'm going to put 0.47 for right now. What you should notice is that when we multiply the fractions, all of these should be out of 42 because the bottom 2 numbers are not changing. I'll show you again with multiplying fractions and I'm going to let you calculate it. This is going to be 10 out of 42. What's that decimal? I want you with your group to finish the tree diagram. Can you finish these 2? We're multiplying. Let's check. How did the end of your tree diagram go? Do we need any help multiplying straight across? So for this one, I did 27 times 5 over 6, and I got 0.23. I should get the same exact fraction as this one because I'm multiplying the same fractions together, just they flip-flopped. This last one, I did 2 7 times 1 over 6, and I got 0.04, so like 4% chance.
Okay.
Yeah. Okay, and then I added on my diagram, will you add this too? This is a winner. This is a winner. Okay, these two possibilities, we have the probabilities of them, but they're not a winning chance. Will you label the winners on your diagram? We're going to add that these are dependent events. Dependent. I think dependence is a little easier to see, right? My odds of choosing two of the same colors is dependent on what I draw first out of the bag. Does that make sense? They're dependent on each other because we're taking a starburst out and we're not replacing it. Any questions on the tree diagram right now? For number 4, we're going to add 0.47 and 0.04. We're going to add our two winners up to answer number 4. We're adding the winners up, so make a note. We're going to add the winners, 0.47 plus 0.04. This, again, is from our tree diagram. We get 0.52. We have a 52% chance of winning the game. Okay. What's the probability that the first starburst was red given, make a note, this is the conditional probability, given that the person won the game? I'm going to write this out in notation. Remember, given is that vertical line. So I'm going to figure out what's the probability of pulling red and being a winner divided by the probability of being a winner. So what's the probability of pulling the first one as red? Go look at our tree diagram. We're looking back up here. What's the probability I pull the first one as red and I won the game? So I pull the first one's red. I follow that along. 0.47 is my probability of winning the game and the first one is red. Then I'm going to divide that by my overall chances of winning. My overall chances of winning. And we will get 0.92. Hold on. So, from the tree diagram, 0.47 is our chances of winning if I pull the first one's red. 0.51, we got that number from here. That's our probability of winning the game. We're going to divide those two. What do we get? 91, 92. So if you pull a red first out of the bag, you have a 92% chance of winning. Questions about tree diagrams?
You understand?
Take a second. You can glue in your notes. You could write them down. We are going to do the check for understanding together. We'll do another tree diagram. 1,000 songs. And then it seems like we have two options for his playlist. What are our two categories? Pop and rock. Pop, rock. It said 40% are pop, so I'm going to just convert it to a decimal, 0.40. 60% are rock, 0.60. Then, of the pop songs, 80% of them are short. So 0.80. Now, probabilities need to add up to 1. My first branches of my tree add up to 1. So these two need to add up to 1. So what is the probability of being a long song? 20%. Good. Okay? Next, it says 25% of the rock songs are short, which leaves how many, what percentage is going to be long? 75, good, 0.75. And now we're going to calculate our end probabilities, which is much easier than the starburst activity because they're already in decimals. So we multiply. So for example, I'm going to do 0.40 times 0.80 to find the probability. And then I'll do 0.40 times 0.20 to find that end probability. I'm going to let you calculate it, and then we'll compare. Your ending probability should add up to 1. Okay? Can you check your end probabilities? We got 0.32, 0.08, 0.15, 0.45. Any questions? Now, we're going to use the tree diagram to answer the following questions. Number 2 says describe the meaning of 80% in the tree diagram. So, given that a song is pop, given that a song is pop, there is an 80% chance it will be a short song. I'm going to also write it out in notation. Bless you. The probability of short, given its pop, is 80%. Okay. Last one, 5 and 6. What's the probability that the song is short? You said what?
47.
How did you get 47? Perfect. We're going to add the short probabilities. So 0.32 and 0.15 from my tree diagram, those were my probabilities of picking a short song. So we get 47%. Number 6 is a little bit of a trickier one. It says given that the song selected is short, given that the song selected is short, what's the probability it's a pop song? So, from my tree diagram, I got 0.32 divided by overall, what is my probability of getting short? Didn't we just find that here? 0.47. So then we can get our overall probability. So when you have a given, you need to look for your total short or your total long and divide in the end. What questions do we have? Your practice problems are 14, 15, and 16.